everyone. Thank you for joining. Thank you for watching or listening. My name is Maria Newkirk. In our group, we also have Rachel Cameron and Aiden Ahern. Today, we're talking about AI versus human alerts. Who do users trust more? So many cybersecurity incidents don't stem from technological failures, but they also result from human ones, as we've learned in this class. A common issue that we've identified is that users will often ignore or dismiss critical security warnings, like antivirus pop-ups, phishing alerts, training, software update prompts, etc. This recurring problem motivates the cause of our study. So, as organizations, like every organization almost now, is increasingly turning to AI-powered assistance to boost security awareness, a key question remains unanswered. Do people actually trust human alerts more, like from the human IT administration team, or will they trust alerts from AI systems more? So our study explores how the source of a cybersecurity alert, being an AI assistant or a human IT assistant, will affect user trust and compliance. We designed a controlled experiment using identical simulated threat alerts that differ only in the source of information. So, by measuring perceived credibility and user behavior across different sample groups, we aim to determine which messenger is more effective to the end user. So, this research that we proposed not only addresses a critical gap in cybersecurity behavior literature, but it also helps organizations tailor their alert delivery strategies for maximum impact and compliance.
Now, let's talk about the research gap in our central question. When we looked at prior research, we found conflicting insights about trust in AI versus human sources. On one hand, there's evidence that people often trust algorithmic advice quite a lot. In fact, a 2019 study by Log and colleagues showed that people adhered more to advice when they believed it came from an algorithm rather than a person. This suggests an AI's alerts might be taken more seriously. On the other hand, other studies suggest the opposite, a bias in favor of human experts. In a recent experiment, participants saw identical advice but were told either an AI or a human wrote it. An overwhelming 93% preferred the advice they thought came from a human. So, trust in AI is context dependent, and sometimes people are skeptical of machine advice, perhaps fearing it lacks empathy or reliability. This contradiction marks our research gap. We simply don't know which way it will go for cybersecurity alerts in a real world scenario. That leads to our research question. Are people more likely to trust and act on cybersecurity alerts if they come from an AI assistant versus a human IT admin? We will investigate whether the source, AI versus human, changes how users perceive the alert's credibility and whether they follow the recommended action. Next slide. Given our question, we set clear objectives. First, we need to directly measure trust in the alert. How confident are users in the validity of the warning? Do they feel the alert source, AI or human, is credible? We'll capture this by asking participants to rate the alert's trustworthiness and sender's credibility. Second, we'll measure what really counts in cybersecurity. Do they actually take action? It's one thing to say, I trust this alert, and another to actually follow through, like installing a security update or not clicking a risky link. So, we will observe compliance behavior in each condition. Third, we want to understand the why behind the numbers. We plan follow-up questions or brief interviews after the experiment to gather qualitative insights into their thought process. For example, perhaps someone might say, I trusted the AI alert because I figure it has no motive to lie and it's always watching the system, which ties to the idea that AI has an inherent absence of self-interest. Another might say, I took the human admin's warning more seriously because I know John from IT will follow up and he's accountable, reflecting the power of authority and accountability. We're effectively hypothesizing two competing outcomes. One, the AI assistant might be more trusted and effective, or two, the human admin might elicit more trust and compliance. It's also possible we find no difference, which itself is an important finding. Either way, these objectives and hypotheses will guide how we design the study and interpret results. Next slide, Aiden.
All right, here's how we plan to carry out the experiment. We'll have a group of participants, ideally employees or people in a work-like setting, and we'll randomly split them into two groups. One group will receive what looks like an alert from an AI assistant. For instance, a notification from Secure AI saying potential threat detected on your account. And then we'll have the other group get the same core message, but attributed to a human. So we'll have John from IT security say, there's a potential threat detected. So by keeping the message itself the same and only changing the source, we'll isolate the variable we care about. We want to see the difference in trust and behavior between these two conditions. What will we measure? Well, first, did they act on the alert? For example, let's say the alert says, reset your password. Does the participant actually go through with it? And how quickly? That's our behavioral measure of compliance. Second, after the scenario, we'll give them a survey about their perceptions. We'll ask how trustworthy they found the alert, how confident were they in its accuracy, and how much they'd rely on the alerts from that source in the future. We're using standard trust scales, essentially gauging if over or under trust occurred. Remember, trust needs to be calibrated. Too much trust in an unreliable alert can be dangerous. I mean, you could follow a bogus prompt, whereas too little trust in a reliable alert means you're missing real threats. So we'll also hold everything constant aside from the AI versus human aspect. The alerts will have the same wording, the same level of urgency, and the same hang on, I lost my spot. Same level of urgency. Same format, just with different sent by line. Perhaps a different avatar, maybe a cute robot icon for the AI, and a photo of John from IT for the human. And during the experiment, participants might think that it's a real security system monitoring. In reality, it's a simulation we control. After collecting the data, we'll compare the two groups on trust ratings and compliance ratings. We'll use statistical tests like t-tests and chi-squared to see if any differences are significant. Finally, we'll gather qualitative feedback, asking the participants why they did or did not follow the alert. This will enrich our understanding. Was it something about the AI that seemed too impersonal? Or conversely, did they trust it because they assume that it's always watching the system? The methodology is designed to give us a clear answer to our question while also shedding light on the reasons behind the user behavior. Thank you
And
for listening.
here are our references. Thank you.
Thank you.